Hello, my name is Alberto Pascal, and today I will be sharing with you my approach on a shopping problem from the CS50 Artificial Intelligence course in Python. First of all, some background. Um, the problem tries to predict the behavior of people that go shopping according to the CSV data provided. In order to achieve this, we will be making use of the sklearn module in Python, and more specifically, a nearest neighbor classification. We will be using the nearest neighbor classifier, but with a k of 1. So that's why it's a nearest neighbor classification. And to solve the problem, there were three functions that were required to be modified, which are load data, train model, and evaluate. Starting with load data, we receive a CSV that looks as the image shown. It's pretty straightforward. Most of the information here is already numeric. There are only some exceptions in the months column, in the visitor type, weekend, and revenue. And well, these values are going to be mapped to a specific type of data. So the steps were creating a flag to skip reading the headers, and then creating a month list so I can store the number of months instead of storing February. We store 1, for example, which is the second position of our month array. And we also prepare the label and evidence lists by declaring them. And then we read row by row, interpreting the results. So for every row in the first 10 columns, we just store the data as is. For the 11th column, we interpret the month and store the month number. For columns 12 to 16, we store data as is, and the remaining rows will be interpreted as 0 or 1 depending on their value. False is 0, 1 is true, and returning visitor is 0. 1, and new visitor is 0. Now for the train model function, thanks to the sklearn module, this function is pretty straightforward too. We only need to create a k-neighbor classifier with k equal to 1. We need to fit the model according to our evidence and labels, and we return the k-neighbor classifier once it's fit. And to evaluate, we mainly depend on our testing data. We divided our data in several segments, so we want to measure both specificity and sensitivity. This is mainly due because our test data can be heavily charged towards having no bias or having bias, and make it seem as if our model is completely accurate when maybe it is not. So we will be iterating through every level and prediction, and keeping track of how many levels are positive and negative, like how many are good revenues and how many didn't give any revenue. We also keep track of how many of our predictions were accurately assigned according to the label. And to calculate the specificity, we divide our accurately assigned negative descriptions over the total negative levels, while for our sensitivity, we divide our accurately assigned positive descriptions over the total positive levels. Let's take a look at the code here. So we can run shopping.py with the shopping CSV. There will be some warnings shown here about the versioning, but overall here we can see the results. We had 4,056 correct information that we predicted, and 876 incorrect information. And the rates were, the true positive rate was of 36.77%, while the true negative rate was 90.47%. We can run this a couple of more times and see the numbers are pretty similar, though they do change a bit. This is mainly due to the fact that I mentioned before, that our CSV data is heavily charged towards having no revenue. So 90% of the time overall, we can properly guess when there will be no revenue, but it gets a little bit harder due to our training data to guess when of the true revenue comes. That would be it. Thank you for watching, and see you all next time.